All right, so last review day before our Chapter 9 test on matrices. We are focusing on the word problems. It's asking us to find a quadratic function. And when I walked around and checked your papers, most of you forgot to do that last step. All right, they're asking you to come up with this quadratic equation. Okay, we're going to use a matrix to figure out what our A, B's, and C's are. The first line here says that when we put a 1 in for x, we should get -2. So dumping that into here, I have a times 1 squared plus b times 1 plus c equals a -2. My second one here, if I dump a -2 in for my x's, I should get a -38. And the last one says if I put a 2 in for all my x's, I should get -6. Okay, so we have our system of equations. Now we have to take them and create an augmented matrix. All right, so 1 squared is 1. We have 1b, we have 1c, and our constant is -2. Our second row, we have -2. It's getting squared to become a 4. Our b term here is -2. C is 1, and we get -38. Last row, we've got 2 squared is 4. We have 2 times b, 1 times c, and we get a constant of -6. Okay? So this is the kind of work I would expect to see on your test. You've set it up, you've dumped your numbers in here, you've created an augmented matrix, then you can use your calculator to do RREF. All right? And what matrix did we get out? We got 1, 0, 0, 0, 0, 1, 0, 0, 0, 1, right? And then what were our constants? Should be -4, 8, and -6. Yes? Okay, so that's your A, B, and C. And now you can take those and you can put them back in for your A, B's, and C's and say that your final function, your A value is -4, your B value is 8, and your C value is -6. Okay, and if this was a test question, could you plug those numbers back in? Could you graph that and then look at a table of values and see if it's fitting the 3 points they gave us? Okay, options to check that. All right, our second question. The figure on the right shows the intersections of 4 one-way streets. You are going to have to be very careful with which way the arrows are going. If you can't read it on your test, make sure you come up and ask. Okay, so looking at the arrows here, this 180 is going in, Z is coming out, it's going into intersection 4, and then coming out is 75. So we're going this direction for that road. Okay, on the top here, we're going this direction. This one is going up, and this one is going this way. Okay, so you can focus on what's going in, what's coming out. Remember that the ins have to balance the outs. Okay, so I'm going to pause the recording. I want you guys to set up an equation for each intersection. What's going into that intersection, what's coming out of it. On these arrow ones, you have to really focus on which direction the cars are moving. So inside here, we have W, X, Y, and Z. That X might be going into one intersection but coming out of a different one, right? What you have to focus on is for each intersection, what are the things going in and what are the things that are coming out of just that little intersection. Don't worry about the other parts. So if I'm just focusing on this piece right here, okay, intersection 1, what are the pieces that are going in? Look at your arrows. From the 160, we're headed to the right, correct? So that 160 cars are going into that intersection. What's coming out on the other side is W. Yes? So for this intersection, this is an in and this is an out. Okay? Looking at the other street, what's going in? The 180. What's coming out? Okay, so ins have to balance outs. All the cars going in have to somewhere come out again. Okay, so for this intersection, we have 160 and 180 going in. What's coming out is W and Z. Okay, now shift to the next intersection. Now we're looking at this. Okay, what's going in? The 360 is not going in. Look at the direction of the cars moving. The cars are going this way. So what's going into that intersection is X, and this is what's coming out. Yes? For the other direction, what's going in? The W is now an in for this intersection. What's coming out is 180. Okay? So have your ins balance your outs. What did we say was going in? W and X. What's coming out? Okay, looking at the next intersection. All right, which ones are going in? Look at your bottom street. We're going this direction, yes? So Y is going in and 30 is coming out for that street. For the other street, we're going up, right? So 180 is going in, and in this case, X is coming out. Yes? Okay, so for this intersection, the ins, we have Y plus 180. The coming outs would be X and 30. All right, last intersection. All right, for this one, our street is going this direction, so the 125 is going in, and coming out is Y for that street. For the other street, we're headed this direction, so going in is Z, and coming out is 75. Does that make sense? All right, so ins are 125 and Z, and outs are Y plus 75. Yes? Okay, that's your start. Now you got to do some rearranging. You want to get all of your W's lined up, all of your X's lined up, your Y's, your Z's, your constants. Okay, so we have to do a little work. Can we completely flip-flop this top equation? Yes. Ins have to balance outs. It can be out equals in equals out. Doesn't matter, right? But we can say that W plus Z, so W, no X's, no Y's, and a Z, has to equal, what's 160 plus 180? Okay. All right. Our next row says W plus an X has to equal, what's 360 plus 180? Okay. The next two equations, we have some variables on each side, so we're going to have to do some moving. I'm going to bring this X over here, so it's going to be a negative X now, plus the Y, and then I have to bring the 180 to this side. What's 30 minus 180? 30 minus 180. All right. Last equation, I'm going to bring the Y over to this side and the 125 over to that side. So the Y is now going to be negative. I still have a positive Z on the left. What's 75 minus 125? Okay. All right, so we have our system of equations. We now have to write a matrix. Okay, what's the matrix going to look like? My top row is what? What's the top row going to be? 1, 0, 0, 1, 340. Okay, second row would be 1, 1, 0, 0, 540. Third row, 0, negative 1, 1, 0, negative 150. And bottom row, 0, 0, negative 1, 1, negative 50. All right, I'm going to pause the recording. Go ahead and do your RREF. All right, looking at what you should have gotten. All right, so the bottom row being all zeros tells me what? There's an infinitely many solutions to this, yes? The solution for part B here is going to just have expressions in it, okay? Part C gives you one specific value to try for Z and tell me what the others would have to be, okay? So to solve it, I'm going to have to see what you're coming up with for equations. So this top row would tell me that W plus Z equals 340. Yes? So if I solve that for W, what would I get? Okay. Negative Z plus 340 equals W. Yes? So when I go to write my system or my ordered quadruple, that's going to be my W expression. Yes? My second line tells me an X minus a Z equals 200. Okay, so if I solve for X, I have to add the Z over. So Z plus 200 is my X coordinate. My third row says Y minus Z equals 50. So again, adding the Z over to the other side, Y would be Z plus 50. And we said Z can be anything. Okay, so that's my solution to the system. Then it says, if construction limits Z to being 50 cars per hour, how many cars must pass between the other intersections? Okay, so that's saying, what if Z is 50? We put a 50 in for all of those. What's my solution going to be? What's negative 50 plus 340? Okay. 50 plus 200. 50 plus 50. And 50. That's just one example of a solution that would work. Okay? But the one I have here in green, that fits all situations. All right. Our next question says a ball is thrown straight upward. The position function and a graph are given below. Use the points labeled in the graph to find the values for G, V sub 0, and S sub 0. We did some of these back as we were going through the chapter. This is our gravitational constant. All right, effective gravity. V sub 0 is the initial velocity. And S sub 0 is the initial height. Okay? This question is a lot like the first one we just did. They are giving you 3 ordered pairs. They're giving you a basic equation to dump those in. You're going to write 3 equations and set up your augmented matrix. Okay? Then go ahead and do RREF. Figure out what your values for G, V sub 0, and S sub 0 are, so you can dump them back into that equation. All right, go ahead and try that. All right, let's check our work here. So the first point says if we put a 1 in there, square it, times it by G, then we put a 1 in for T here. We have 1 V sub 0, we have 1 S sub 0, and we are supposed to get 76. Okay. Second one, we've got 1/2. This time we're dumping a 2 in for X, or for T. And we are supposed to get 120. And the third one, we are putting a 3 in, and we are supposed to get 132. Okay? So, 3 squared, 9. Half of 9 is 4.5. Don't forget that 1/2 when you figure out your matrix. Okay? So my matrix, half of 1 squared is 1/2. My next number is 1, 176. Second row, 2 squared is 4. Half of that is 2. We said 3 squared is 9. Half of that is 4.5. All right, so there's your augmented matrix. You do your RREF, and we get this one. All right, first number was -32, 92, and 0. All right, so what does the top row tell me? That G is -32, okay? V sub 0 is what? 92. So initial velocity is 92, and S sub 0 is 1 S sub 0, right? Is 0. So S sub 0 is 0. All right, remember, S sub 0 is your initial height. Does it look from the picture that that's starting at time 0 at a 0 height? Yes, the ball's on the ground. So my equation, if I take these now and dump them back in, I say S of t is 1/2 times -32. Let me just put that as -16. T squared plus 92t plus 0. Okay? Now, part B says, find and interpret S of 5.5. So, if I do 5.5, dump that in for my t value, I've got -16 times 5.5 squared plus 92 times 5.5. And our answer was what? 22. So what does that mean? Find and interpret. We found the answer. Now what does it mean? Okay, so after 5.5 seconds, the ball is 22 feet off the ground. Okay. Now, the last part says, after how many seconds does the ball reach its maximum height, and what is the maximum height? If you look at the graph, all right, at 3 seconds it says we're at 132. That's pretty close to the maximum, yes? We don't know that it's exactly the maximum, but it's got to be pretty close from the picture. So that gives us a frame of reference for our answer. All right. How do we find the vertex of a quadratic? Okay, so my x or t value is -b over 2a. In this case, my b term was 92, so -92 over 2 times -16. What's -92 divided by -32? Okay. So that 3 seconds with a height of 132 was pretty close. Our maximum is actually at 2.875 seconds. Can we then dump that back in just like we did here and figure out our height? Okay. All right. So plugging that in, we should get a height of 132.25 feet. Okay? Yep. All right. For this one, it says the nutritional content per ounce of 3 foods is presented in the table on the right. If a meal consisting of the 3 foods allows exactly 2,200 calories, 117 grams of protein, and 6,000 milligrams of vitamin C, how many ounces of each kind of food should be used? Okay, so we have 3 different criteria, 1 for calories, 1 for protein, 1 for vitamin C. Yes? We need to create an equation for each of those. So my first one, 100A, 200B, 300C gets me 2,200. That would be my equation. Yes? For calories. For protein, I have 15A plus 9B plus 9C equals 117. That's my protein. For vitamin C, I have 350A plus 750B plus 400C equals 6,000. So again, you are going to create an augmented matrix . You're going to do RREF. When you do that, you should end up with this matrix. Now, what does that mean? What does the first line tell me? A is 3, second line tells me B is 5, and C is 3. So my answer here would be, I need 3 ounces of food A, I need 5 ounces of food B, and I need 3 ounces of food C. Our last question says, in a certain country, the proportion of voters in each age group registered as Republicans, Democrats, or Independents is given by the adjacent matrix. We're going to call this matrix A. Okay. Then it says the distribution by age and gender of this country's voting population is given by this matrix. Okay. It is asking you to find A times B. So could you enter these 2 matrices in your calculator and multiply them? Yes. All right. When you do that, this is what we end up with. All right. Now, use the labels. All right. We've given you labels for columns and rows. We are taking the age group here times the same age groups there. Yes? A row times a column. Those things are going to kind of cancel each other out. What we are going to have left would be these and these. So when I look at my answer matrix, this would be Republicans, Democrats, Independents, and this would be males and females. Okay? Now it says, what does this answer tell us? So it's giving us a breakdown of Republicans, Democrats, and Independents by gender? Yes? Okay. I multiplied them, yes, using the calculator. A times B. Yep, row times column. All right, assignment. On page 932, you are doing 6, 12, and 56. On page 876, you're going to do 47 and 48. And on page 902, you're going to do 64.